Multiplication of radicals. Learning target. I can multiply radicals with same and different indices. In multiplying radicals, we consider two different cases. Case 1, multiplying radicals with same indices. To multiply radicals with same index, so we just multiply the coefficients, multiply the radicands, and simplify if possible. First example, given square root of 3 times square root of 12. So the two given radical expressions have same index. To get the product, multiply the coefficients. So we have 1 and 1. 1 times 1 is 1. Since the coefficient is 1, there's no need to write the numerical coefficient. Step number 2, multiply the radicands 3 and 12. So we have 3 times 12. Simplify. 3 times 12 is 36. And square root of 36 is 6. So this is now the product of square root of 3 and square root of 12. Another example, 3 square root of 2 times 5 square root of x. Again, the two radical expressions have the same index. So just multiply the numerical coefficient. 3 times 5. 3 times 5 is, I just write 3 times 5, and then combine the radicands 2 and x. 2 times x. 3 times 5 is 15. Square root of 2 times x is 2x. Square root of 2x is already simplified because there is no perfect square factor of 2x. So this is now the product of 3 square root of 2 and 5 square root of x. Third example, square root of a multiplied to square root of a raised to 5. Again, step number 1, multiply the numerical coefficients. Since both are 1, so there's no need to write number 1. Proceed to step number 2, multiply radicands. We have a times a raised to 5. A times a raised to 5. Okay, if you can still remember the product rule in loss of exponents. So if we are multiplying two exponential expressions with same base, just copy the base, add the exponents. So we have square root of a raised to 6. A raised to 6 is a perfect square number because the exponent 6 is divisible by 2. So extract square root of a raised to 6, that is a raised to 3 or a cube. Okay, so this is now the product of square root of a and square root of a raised to 5. Second case in multiplying radicals. Radicals with different indices. To multiply radicals with different indices, we follow the following steps. First, find the LCM of the indices. Second, write each expression with the new LCM as the index. Third, find the number that you would multiply each original index by to find the LCM, and make this number the exponent of the radicand. Fourth, perform case 1 and simplify. Example, cube root of 4 multiplied to square root of 5. The two given radical expressions have different indices. To get the product, we follow the steps in case number 2. Step 1. Find the LCM of the indices 3 and 2. LCM is the least common multiple. The multiples of 3 are 3, 6, 9, 12, and so on, while the multiples of 2 are 2, 4, 6, 8, and so on. So the least common multiple of 3 and 2 is 6. Therefore, our LCM is 6. Step number 2. Rewrite the given expressions with the LCM as the new index. So we will write cube root of 4, but instead of cube root, we will make it 6th root. 6 root of 4 multiplied to 6 root of 5. Again, what we did in step number 2 is just we rewrite the given expression with the LCM as the new index. So from cube root of 4 it became 6 root of 4, square root of 5 became 6 root of 5. Step number 3. From our expression in step number 2, 6 root of 4 multiplied to 6 root of 5. Okay, step number 3, find the number that you would need to multiply to the original index by to get the LCM 6. So from the original index 3, it became 6. What number that we will multiply to 3 to make or to get 6? Okay, that number is 2, and 2 will become the exponent of the radicand 4. For the second expression, from the index 2, it became 6. So what number that we will multiply to 2 to get 6? That is 3, and 3 will become the exponent of the radicand 5. Step number 4. Since the expressions or the two given expressions are now have same index, then we can now perform steps in case number 1. Okay, let's simplify first 4 squared and 5 cubed, and that is 6 root of 16 multiplied to 6 root of 125. So case number 1, since they have the same index, we will just multiply the radicands. Copy 6 root multiply 16 times 125. We have 6 root of 16 times 125 is 2000. Fifth example. Given cube root of 3 multiplied to 4th root of 3. So the two radical expressions have different indices. Step 1. Let's find the LCM of the indices 3 and 4. The least common multiple of 3 and 4 is 12. So our LCM is 12. Next step, rewrite the expression with the LCMs, the new index. So cube root of 3 will become 12 root of 3 multiplied to 4th root of 3 will become 12 root of 3 also. And step number 3, step number 3, find the number that you will need to multiply to the original index to get the LCM. So from the original index 3 to get 12, we will multiply 3 by 4. So 4 will become the exponent of our radicand 3. In the second expression, the index is 4, or the original index is 4, and from 4 to get the LCM 12, we will multiply 4 by 3, and 3 will become the exponent of the radicand 3. Simplify, we have 12 root of 3 raised to 4 is 81, multiplied to cube root 12 root of 3 raised to 3 is 27, and then step number 4, perform case number 1. Since the two radical expressions have now same indices, so multiply radicands 81 and 27, copy the root, which is 12 root. 81 times 27 is 2187. Thank you for listening.